Okay, so this is also a solution for this, which means that this also satisfying this relation. Let's see now. So let's show it for you. So e to the alpha y times sine alpha x is satisfying this relation. But let's see if this also satisfies these four conditions. When x is 0, u should be 0. Put 0 here. Sine of 0 is 0. 0 times this is 0. Also, so the first condition is okay. Put x pi here, and this should be also, this should make u 0. If you plug pi here, the sign, this should be 0. But how? This is 0 when alpha is an integer. Okay? And it's not 2 pi, 3 pi. The sign of these are, or minus of the sign of these are 0. Okay, so let's change to n. X, n is an integer, and the alpha also n. So this is a solution satisfying this relation and the first two conditions. But what about the third one? If y be equal to infinity, u should be 0. So if y be infinity, this doesn't depend on y, so let's check this one into the n y. If y be infinity, then only if n be negative, this should be 0. Okay, and you know, if you could think of the limits, the limit of this as y approaching to infinity, you know, makes no difference. So then n should be negative. Okay, let's see. Okay, let's see if this satisfying the last condition. So put y equal to 0, u, this is u, okay, u should be x cubed. So put y 0 here, this should be e to the 0, which is 1. So u would be sine nx. But this is not equal to x cubed for every negative integer values of n. But we don't give up here, and as I mentioned before, this is a linear equation, and every, you know, this is a, you know, this is not just one function. Sine minus x, sine minus 2x, sine minus 3x. No, they are satisfying this relation and the three conditions. But since it is linear, then every linear combination of the solutions is sine of nx like this should satisfy this relation also. For instance, let's say this is a linear combination of a1 sine of minus x plus a2, and a1, a2 are constants, okay? Sine minus 2x plus a3 sine minus 3x should satisfy this relation. And what about these conditions? Okay, if you put x equal to 0, you become 0. If you put x equals to pi, you become 0, because all of the signs would be 0. If y infinity, where are you, y? Oh, okay, yeah. Oh my god, here I missed e to the ny. Here n is minus 1. Here e to the minus 2y. And here e to the minus 3y. Okay. If y be infinity and here is positive infinity, okay, then every of these is equal to 0. So u is 0. So every linear combination of these solutions in this form, in which n is a negative integer, is satisfying this relation and the three conditions. But again, every linear combination, for instance, you put, for instance, let's put some numbers into these, say 5, this is 8, and this is, say, 3. So again, this is not equal to x cubed. But again, we don't give up. But okay, let's say that every linear combination of finite number of solutions would not be equal to x cubed, satisfying the fourth condition. But what about an infinite, the linear combination of an infinite number of the solutions? And this is not that strange, because for instance, in the Taylor series of functions, for instance, e to the x, let me e to the x equals to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus infinite number of terms. But it is not equal to a finite number of such terms. So let's consider an infinite number of solutions, a linear combination of an infinite number of solutions in this form, and let's see if the infinite sum would be equal to x cubed. And this is linear combination. Let's show that like this. A1 e to the n is minus 1 here, minus y, sine minus x plus a2 e to the minus 2y, sine minus 2x, here n is minus 2, here n is minus 1, plus a3 times e to the minus 3y, sine minus 3x, plus, and an infinite number of such solutions. And let's see if this would be equal to x cubed. Oh, sorry, here we should put 1 equal to 0, so we don't have this e to the y terms. And let's see if this would be equal to x cubed. And here sine of minus of something equals to minus of the sine of that thing. So here minus here, and here minus goes here, and here the minus goes here. Okay, and let's show this new coefficients by b. b1 plus b2, and this minus a3 by plus b3. Okay, so, and it turns out that it's not like that for every values of b1, b2, b3 and all the coefficients. This is equal to x cubed. And if b bi, say general for b equal to 2 over pi, the integral from 0 to pi of x cubed times sine nx dx. That if the coefficients be equal to this, and here n is, here n is the coefficients of x here, okay. For instance, for this b1 would be this integral when n is 1, b2 would be this times this integral when n is 2. Okay, this is called the Fourier series, or the sine Fourier series of x cubed. And here, instead of x cubed, if it was f of x, then here this would be f of x. Okay, this is another area in which series appear, and we need them. Okay.